Video I'll be explaining to you about law of conservation of mass and law of definite proportion. It is also called law of constant composition. The first one, law of conservation of mass. Law of conservation of mass. Okay. Law of conservation of mass states that for any chemical reaction, the total mass before the reaction is equal to or is same after the reaction. Again, the total mass remains the same before and after the reaction. Say for example, A reacts with B to give C and D. Okay, if A had A gram, B had B gram, and we got C as C gram and D as D gram. Okay, then according to law of conservation of mass, the total mass of the reactant will be equal to the total mass of the product. Okay, this is what it states. Now moving on to the next one, that is law of definite proportion. Okay, it is also called constant composition. Law of definite proportion. Okay, law of definite proportion states that a chemical compound, okay, a chemical compound will have that same element, okay, and those elements will be combined in the same ratio. It will never change. Say for example, water. Okay, water will remain as H2O at any condition. Okay, so its ratio will be 2:16. We have to see their mass. Okay, the ratio. So 2:16 or 1:8. Say another example, carbon dioxide. Okay, their composition will be always as 12:32. Okay, this composition will never change. Okay, that is what the law of definite proportion or law of constant composition states. Okay, I'll be putting up one task. Okay, I'll be giving you one task based on law of definite proportion. Okay, law of definite proportion. So here it states, okay, here it's like this: 1.375 gram of copper oxide, okay, or cupric oxide is reduced, okay, is reduced and gave 1.098 gram of copper. Okay, this is first reaction. Okay, in the second reaction, copper, okay, having 1.179 gram, okay, 1.179 gram of copper, okay, is oxidized. Okay, is oxidized, okay, to form cupric oxide. Okay, is oxidized to give 1.476 gram of cupric oxide. Okay, now we have to find out whether the law of definite proportion is valid or not from this question. Okay, so two reactions. In the first reaction, this 1.375 gram of cupric oxide is reduced and gave 1.098 gram of copper. Then in the next part, okay, in another reaction, 1.179 gram of copper is oxidized to give 1.476 gram of cupric oxide. So how do we calculate this one? Okay, I'll give you the first part. Okay, for the first reaction, you try to solve for the second reaction. I hope you have noted down the question. So I'll erase this one again, open this one, and I'll show you. See, mass of cupric oxide is equal to 1.375 gram. Okay, you have to follow the same method, the same process for the second reaction as well. Okay, so I'll show you the first reaction. Okay, first method. The second reaction will be the same only, and find out whether the percentage, okay, the mass percentage of copper in both the cases is same or not. So mass of copper equals to 1.098 gram. Okay, now mass percent of copper is equal to, see, 1.098 divided by 1.375. Okay, this is the mass of the copper, this is a cupric oxide. Okay, so into 100 we got 79.86%. Okay, you calculate by yourself, you will get this one. Now this same process you apply for the second reaction as well. Okay, and you will get, if you get this same answer, it means the law of definite proportion is valid. Okay, so that's all in this video. I'll be explaining to you the remaining laws in the other videos. I hope you can get the answer. It will be the same method, so you try it.